Today we'll be learning about backpropagation. This column right here is the activation, which cannot be changed, and all these wires and tetherings are the weights and biases, which can be changed. Today we'll be finding number two. Right here in this column right here that has been added is the weight numbers go. As you see here, two is not in the right spot, so it has a bigger arrow, which needs to go up. And you can see three with the biggest red arrow means it's 100% on the right spot, which means it needs to go down. Same with four, same with five, same with six, one, two, basically everything, because they need to be moved to where they belong. But as of right now, we're looking for two, so it needs to go to the top. Right here, we have the sigmoid function, which has the bias, the weight, and the activation. In this case, to change anything in the situation, we need to be either increasing the weight or the bias or changing the activation. Right here, we have two and a bunch of networks connecting to it. The ones that are yellow are the ones that see the number two. The ones that are not are dimmed out, basically not fully white, as you see here, which they're thinking about number two. So we need to get them to the point where they could see number two. As you can see here, we have the null network and a bunch of arrows and everything else. I wish I would get to it. And see here, we have the activations of the first picture, the arrows, and also the numbers, and our target two, which still needs to go up. This column right here is the neural network before that, and every column here is a neural network before that. As you can see, there's more arrows. As you can see, like this column, it'll basically be the same thing, okay? And then we'll go back, 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 which will get to the averages. See here, the number two was the target, but also you still need to move the other numbers, which is like 5, 0, 4, 1, 9, as examples here. See, one row would basically be one neural network. You can see here, two, we need to go back, down. Then again, it'll go back down, it'll go back down, and different, each time different in each neural network. See here, this one needs to go up, this one needs to go up, well, then it'll need to go back down. Simplify it better, we have a bunch of random numbers here. Each row would basically be a network column. You can see here, we're going to randomize it to give us more numbers. And in each row, we'll do the same thing. We'll find which number needs to move up and which numbers need to move down. If you were to do a gradient descent map, it would basically like this. As you see, gradient descent, it'll go down one at a time each time. But for a stochastic gradient descent, it would be going down as it will get the numbers. But since we're doing a new row, which is a new neural network, it will go back up and gain the knowledge and then go back down as it's got the numbers done. Then it'll go back up, then it'll go back down, and go back up, and then it'll go back down. To simplify backpropagation is basically getting the furthest neural network column, seeing where the target number is, moving it to the top, and then moving the ones to the bottom as they are not needed in case of doing one at a time, into which you'll do it each time to each column. Then after that, get their average, into which you're able to get the numbers into their right spot. Right here, we have a large language model and these dials. Technically, to simplify all this, it is that a dial is there to be turned and twisted for a situation, as it is gathering all the information in the world from multiple sources. It will turn its knob depending on what type of situation it would be. With large language models, for them to gather all the information and also process everything, from which is okay. Take 14. 3, 2, 1. With large language models, They first start with the pre-training, which was what I said last time, was them gathering a bunch of information like random quotes, random paragraphs, and finding its right dial of percentage. An example would be fill in the blank, basically. Basically, be like, they'll gather the paragraph that was read before, or maybe the paragraphs now. It will get context clues of what you're talking about. Like, large language models has two steps, basically, which will go to pre-training, which is what I just said before, was taking a bunch of data or paragraphs as data and filling in, and would basically make it fill in the blank, depending what dial it is on, which would be like, what is the worst food in America? They'll take that, fill in the blank, and basically give you, as you said worst. It would take the worst, it'll pull the knob in, change it from like probably from best, as you said worst now, change the knob, and then give you information from that situation. But then there's also steps where just from gathering data from paragraphs, it would have to come from people themselves, as they would take a question and see and delete ones that don't work with that question. That would give you the right answer. In the end, large language models basically gathers data from not only online internet sources, from random paragraphs, it also gets trained into saying by people and just saying what would be a better answer than others. An example would be if you use ChatGPT now, some of them say, would this answer be better or the other answer be better? Sometimes, as it's not, sometimes it would not give you always one answer. It will give you two different options to try to fit in what is your what is the correct answer for what you're asking for. Also, thank you, Three Blue, One Brown, as their video was what I was using to learn and relearn about propagation and learning of large AI.